we are going to learn how to use or learn the structure of the 5542. So you have to go to internet and download a document on SLE5542. So I'm going to open this now. This is the document you get. This is a 6-page document, and as you can see here, SLE5542 has got 256 byte memory with the write protection function and the programmable security code. Put in simple words, so this has got 256 bytes of RAM, memory, and you can write protect some section of the memory, and it's also the password protected. So that's what it all means. So just scroll through that. What we'll be interested is this is a nice explanation about this particular card. It says it's 100% compatible with SLE5542, and it has got 256 bytes EEPROM and the 32-bit protection memory. So what it means here is, out of 256 bytes, only 32 bytes can be write protected, because this is the place where the manufacturer code and other things are stored. And the password has got 3 bytes, and this particular product refer these passwords as a programmable security code, and all other things are very technical. It uses a 2-wire link protocol, which is not of more interest for a developer. And so I think other thing which is very interesting will be these are called the synchronous transmission cards. So probably if you're looking for any documentation, you can look for this word synchronous transmission as well. So for a developer, what we'll be interested is, so as you can see here, the contact pins are explained very well here. So it says VCC, ground, RST, the clock, and input output are not connected. And as a developer, I would be more interested in this part of the document, more or less the last page. So the document is also very simple, and what this document says, or what this diagram says, is SLE5542 has got 3 different memories inside. It has got the main memory, it has got the protection memory, and it has got the security memory. And this is very interesting here. So if you look at this line, this is the read memory line. So there is just a straight line from here to here. So that means the reading is possible always. So you don't need any password verification before you read. Everything can be read. You can read the main memory, you can read the protection memory, and you can also read not everything about the security memory, because the security memory has got the password as well. So you can read only the error counter. So I'm going to talk about all these things in more depth in the later videos. Interesting bit here is this like a small switch. So this switch refers to the updating the main memory, and here also updating, if you see this switch here, updating the protection memory. The switch indicates password protection. So before the main memory or the protection memory or the password memory can be changed, you have to first authenticate. You have to first prove that you know the 3-byte PSC code. So I'm not going to go any more technical details here, but So this explains, the SLE5542 has got 256 bytes. In addition to this, I would recommend to download one more document. So that is the SLE5542, because we know that SLE5542 is 100% compatible with SLE4442, and that document has got more interesting information as well. Next, go to internet again and look for the document called SLE4442, and you can download this document from the manufacturer website directly as well. And this has got more information about this SLE5542 as well. So this is a 35-page document, and it is the document is really interesting. You can understand, but this document speaks more about the technical side, about the signals, and I'll just show you one of the, as you can see, something interesting here as well. So there's also one more card called SLE4432 before this, and the difference between these two is, looks like SLE4432 doesn't have the password protection. But if you want to understand the 5542, which I'm showing pretty soon, so it is, I would advise you to read this document once, and after this you can understand all the commands used by ACR39U very well. So this has got, to summarize, it speaks about various memories and configurations, and what are the commands that are used. This is pretty interesting here, this diagram. So again, we have seen this a different version of this document. The read is possible, but the write has to go through the security logic, and writing for both protection memory as well as main memory. So as you can see here, this is more technical as well. So you can see it speaks about the signals, so clock, RST, SIVO. For a developer like me, I don't think we need to worry more about this. So we just need to understand what are the commands, and what is the command code, and what is the parameters we have to send. And just I would advise you, it's a very interesting document. So I would say this is like a must to read before you start using the 5542. Now this is a software I've written to learn and understand how this contact smart card and memory card works, and we have got the ACR39U connected, and just something I would like to show before I show the working of SLE4442. As you can see here, out of these 5 sample cards, so I already got 2 which are completely unusable because I was learning and playing, and one card got the password locked, so I just forgot what was the passcode, the PSC code, and the other card, all this protection memory is blocked. So these things can happen while learning, and probably I just want to make you aware that when these things happen, you can't undo it, so it will be a waste. You just have to bin these tags. Okay, I'm going to insert my third tag. I got 2 spare as well. Probably by the end of this video I'm going to destroy this this tag also. So I'm going to insert. So as soon as you insert that, you will get a beep sound, and the first thing we do is get the readers. This is very similar to what I have done using the contactless reader writer software. So this reader writer is recognized as ACS ACRU ICC reader 0, and I'm going to connect. So this is the software, or this is the screen I have developed to understand both 5542 and 4442. So I'm going to just go through this as a normal user. Probably the next video onwards I'll be explaining you in depth. So first thing you have to do is you have to select the card. The documentation explains what commands you have to pass to the tag, and I also got the command tabs here that shows what is happening here, what commands are sent to the reader writer, and what's the response you get from that. And these are very well explained, in the ACS document. So after that, I'm going to bring the entire 256 bytes to this software. So click on go, and the first, so this is the 256 memory. I have laid this out into 16 bytes in a row. So I got 16 bytes here, and on the left side, see, every memory is addressable and changeable. So the memory address starts from 0 and goes up to 255, and the first 32 bytes of the memory can be protected against write. So that's what this is, the protection memory. I've highlighted that with the yellows. So you got the protection memory, and on the left side you got, sorry, this is the protection memory, and we also have the security memory, which is on the top section here. So when you buy this this card, some of these memory bytes are already protected, and there are some manufacturer details and other information about the card which the manufacturer doesn't want an end user to change. So if you click on the read button, I'm reading the protection memory here, and I've just highlighted all the bytes that are protected by default. So there are, I still don't know what are these bytes. Probably in the later videos we'll understand more about why these are protected and what exactly these protected bytes mean. So here I've shown all these addresses. So address 0 to 3 are protected, and 6 and 7, as well as 21, 20, 23. Okay, and I've got, you can also see the hex. So probably now this makes sense here. So the first 4 bytes has got something to do with the ATR. So I'm going to understand this in my later videos. So you can read, there is a command to read any part of the memory. So I have given, say for example, if I click this, I'm sending a read command to read the memory starting from address 48 and 16 bytes. So that's what the documentation mentions about. The read operation, you have to specify the starting address and the number of bytes to read. You can see the messages, what's happening here, and let us, as I mentioned before, as the documentation said, the write to this tag is protected, means you must have the password. So the default password for this tag, what I have got here, is all 3 FFs, and I'm going to write something and see whether the write is possible. So I'm going to go to this address 32 onwards. I'm going to edit it. So I'm going to try to write hello world. So I'm letting you type only 16 characters here, and I'm going to write this to the memory. So somehow what I noticed is you don't get any error with this write operation. I know the write is not possible because the writes are protected. If I try to read again, you can see that you got back the old value, so write did not happen. So before you write, you have to authenticate, or you have to send the correct PSC code to the card. So the codes are as I mentioned before, every PSC code has got 3 bytes. So we know the default password for the tag. What I have is all 3 FFs, and first thing I'm going to do is authenticate. So if I click on this authenticate button, I send these 3 codes to the card. So I know that the authentication is successful now. Let's go and try to make the change this time. Edit. So hello world again. Okay, and the write. So if I have to check if write is okay, I just have to try to read again. Read, so it's the same. So that shows the write is only possible after successful authentication. There's one more interesting thing here is called error counter. The way the password is locked is very interesting. By default, we are allowed only 3 wrong passwords. So what you see here is 7. It's in fact the binary 3s. So it's a 1 1 1. So after authenticate, you get back the value of the error counter. If it is 1 1 1, it means I've got 3 more choices, and also it means it's a successful comparison. If I assume that I send this wrong password 3 times, then if you get the return as a 0, so that means the card is locked. You cannot even though you know the correct password, you cannot authenticate. So this is what I did in my first card I showed you before. So the entire card is locked. You cannot write anymore. So you have to be careful with that. Probably when we integrate this type of card into our software, after we do our customization, after we write all the required data to the card, we can manually set the value of error counter to all the 3 zeros possible. So there is a command to change the error code, which I'm going to cover in my next videos. So what we have seen now is how to read and how to write, and how to get the protection memory bits, and I'm going to show you how to change the passcode. So remember, before you change the passcode, you must authenticate. So I'm going to change the passcode starting from the passcode byte 1 to A1, A2 and A3, and hit on change code. So there is a separate, if you see this documentation of this product, it clearly mentions what command you have to send to change the passcode. So now I have changed this passcode. Let us try. I'm going to close this. I'm going to take out this tag and try again. This time I'm going to try with the default password Fs. So first thing you have to do is click on the select card and click on the go. So you can reading is possible, and as you can see here, we have changed the memory address 32 onwards to hello world again, so it's written. Get the protection bits as well. So I'm going to authenticate. If you try to, okay, let's try to authenticate that. So authenticate, so it says authentication error. So it's possible to read this error counter. There is a, you can see, basically you can read this entire security memory, the 4 bytes of security memory. There is a separate command to do the read also. If I click on the read, you can see that password cannot be read, it's all zeros. That's fine. But what has happened to my error counter? It was 7 before, so now it has gone to 3. So one of my 1 bit has been consumed. So this has been gone to 0 now. Let us try once again. So I've got only 2 more chances. So I got on 2 chances. So that's why you see here number 3. This is the binary equivalent of number 3. So I'm going to authenticate again with, let's try to guess, say A2, A4 and A6, and authenticate. So it's error. Try to read this memory. I got 1. I just got 1 last chance. If I try to authenticate now, I'm going to lose this card. So let's not do that at this stage. I'm going to put the correct password and click on authenticate. Yes, you got back the number. Error counter got reset to number 7. So you got 3 more chances. So that is how the authentication works. And again, keep going, keep reading the documentation, and if you want to understand this better. Next, I'm going to show you how to lock a memory byte. You can lock only the first 32 bytes. You cannot lock the remaining memory bytes at all. And there is a separate memory called protection memory inside this card, which is 32 bits long or 4 bytes, and each bit controls the corresponding byte here. So there is a command in ACR39U to change the protection, or to protect a memory. So assume that I want to protect the address 8. So you have to send address 8 to that command. So I'm going to click write, and now I'm going to read the protection memory again and refresh the grid. So yeah, so nothing happened here. So the reason is, if you remember, the writing to protection memory and the main memory is password protected. So we have to first authenticate. So what I say authenticate, the documentation calls that as comparing. So the document speaks about comparing the PSE code. So we know the password is A3, A2 and A1. So I'm going to authenticate success. Now let us try to write again. So I got protection okay. If I try to refresh, and you can see that the bit here 8 is set to 1, and I have just highlighted that address with the red. And so I'm going to revert back this passcode, and I'm going to set this to FF. We are still in the authenticated state because that's what I have shown here. This is a green text, means it's authenticated. So I'm going to change, and you got the password changed. But one thing I noticed in this particular tag is you can read the password, so which is not very common if you compare this with the other tags. So I'm just going to show you now what I mean. So now we know the password is set to FFs. So I'm going to read it. I'm going to set this also, because when you hit this read button, I'm sending a command to read the security memory, which returns me 4 bytes. I'm assigning them as I'm showing on the screen. The first byte is error byte and so on. So if you click the read, as you can see here, you are able to read the passcode after successful authentication. So it's not a big problem here because we already know the password, and so reading it's not a big issue, but you just have to keep in mind the password or readable here. So in the next videos I'll be going through everything what you did now, but in more depth. We'll go through, it's a walk through the document of SLE5542 and also the command structures of ACR39U, and along with this software, so that you understand better.